Hi students, welcome to another video on OPamp circuits. In this video we'll see some conceptual electrical concepts while solving the OPamp designs. So in this circuit, okay, we are supposed to find what are the output voltages of four different OPamps: V01, V02, V03, V04. So if you can carefully look at the first circuit, which is V01 here. So if you look at this configuration, it's actually an inverting amplifier where the output voltage V01 is given by R2 of S minus of R2 by R1 into V1. So if you substitute all these values, this becomes minus 3.3 by 1K multiplied by zero point 0.5, which happens to be minus 1.65 volts. So this is what is V01. And this V02 has got two inputs, V01 and V2 as the input for this. I have written the output expression for V02, which happens to be, okay, now since R4 and R3 are 1K, it's like, okay, minus of 1K by 1K, and V01 is actually minus 1.65, and plus V2 is actually of course, so let me take V2 as 1 volt. So if it is 1 volt, it is 1 into, so R6 is 1K by 3K multiplied by 1 plus R4 by R3, which is again 1K by 1K. If you solve all this, okay, this will go, and it is 1.65 plus, so this will go, and you end up with 2 by 3. So 2 by 3. So this happens to be 2 point, let me just find out. It is 1.65 plus plus 2 by 3. Happens to be 2.31 volt. So here I have 2.31 volt, and here it is 2 volt. Since it is having an open circuit configuration, then V03 is actually, since V minus is more than V plus, so I'll going to end up with minus Vsat. So since I'm using it as plus 15 minus 15 as Vsat voltage, so then this happens to be minus 15 volts. So this is what is V03. Coming to the last V04, so we are supposed to find what is V04. Now what will, because now here it is minus 15 volt, so this is minus 15. So what we'll usually do is, okay, you have a potential divider here, it will become minus 7.5, and then so you tend to write V04 is equal to minus 7.5 into of course minus of 100 by 1000. You write it as 0.75 volt as the answer, but this is the wrong answer, because you tend to assume that, okay, this minus 15 volt will be potential divided and you'll have minus 7.5, that is amplified by 0.1 times, minus 0.1 times, which will give you 0.75 volts. But actually this is not the correct answer. So then what is the correct answer? So now if you see this, the voltage at here is 0. So because we are assuming A naught to be infinite, the voltage here also 0. That means there is no potential difference between the inverting terminal and non-inverting terminal. So here also it is 0. Since R8, one of the end is grounded, the other end is also 0 volt. Typically you don't have any voltage difference between this point and this point, so that now this is like a redundant resistor. So when this becomes redundant, when this is minus 15 volt, so minus 15 is your input voltage. Now it is no more minus 7.5, it is minus 15 into, this is the input voltage, and the gain is minus Rf by R1. So it is so and so. So you will end up with 1.5 volt. So the correct answer over here is, it is 1.5 volt at V04. Okay, you may argue that, okay, does this has no meaning? Yes, this doesn't have any meaning here because the potential on either side of R8 is 0. So is there any way that okay you consider R8 and then still say this V04 is equal to 1.5 volt? Because if you simulate, you'll certainly get 1.5 volt. So maybe what you can do is you can just okay configure this circuit in any spice simulator and try to find out what is the voltage. So this voltage is always zero point 0.1 times the voltage here. This is even though you put 10k, 100k, whatever the resistance you put, it is 1.5. So let us try to understand what is the significance of that. So now, of course, if I put something other, so then it's a okay. We'll just find out what is the value here. So now uh, I will just rewrite only this part of the circuit. So what I'll do here is I will write. Of course, now let us analyze by considering R8 also. So now this is the original circuit what I have. This is minus plus. I will ground this. So this is now the value. This is what I'll get. This is now R9. This is 100 ohm. So this is R7 1 kilo ohm, and this is R8. I named it as. So this is also assumed to be 1k. So this is, let me say it as Vx, and later say let us write afterwards as minus 15 volt and try to find out what is V naught. So let us find out what is V naught here by considering R8. So now with this circuit, so I can write using Thevenin's theorem what is the voltage source looking from this end. So I can rewrite this part of the network as using Thevenin's theorem. I can replace that voltage by V Thevenin, and the internal resistance associated with that V Thevenin is R Thevenin. So now this is what this is replaced, which you had it as Vx. Now that is now replaced by Vth, and this R7 R8 is now replaced by. So I'll write the remaining part of the circuit as it is. This is now minus plus this. I will write the R9 whatever that I had earlier as it is. So this is R9. So this circuit, okay, now this circuit is now this circuit or this part of the circuit is replaced by this. So this remaining part remains as it is. So I want to find what is V naught. So what is V Thevenin now? V Thevenin is nothing but the voltage across. So it's voltage across R8. Because let me isolate this. Let me isolate this. This was my Vx. So this was R7. This was R8. Let me ground this. If I measure what is the voltage here, so what is the voltage and what is the resistance? If you measure what is the voltage here, it's actually I into R8. So what is I? It is Vx by R7 plus R8 is your I multiplied by R8 is my VThevenin. So what is VThevenin? It's actually Vx into R8 by R7 plus R8. Similarly, what is R Thevenin, for finding Thevenin, you ground this and you measure the resistance here. So when you ground this, these two will become parallel. So Thevenin will become R7 in parallel with R8. This is my Thevenin. Suppose if you substitute the values, then Thevenin will become, this is now minus 15 into, this is 1k by 2k, because these two are 1k, it will become so and so. So now this you can see it is minus 7.5 volt. So now this is minus 7.5. If this was minus 15, then this becomes minus 7.5. Then what is Thevenin? Thevenin is nothing but R7 R8 divided by R7 plus R8, which is nothing but 1k into 1k by 1k plus 2k, which happens to be 500. Sorry, 1k plus 1k, which is 500 ohm. So now you have a 500 ohm resistor. So this circuit what you had, of course, as per this we were getting 1.5. Let me write it as 1.5. Let me find out how much the voltage that I'll get here. So is V naught is equal to, as per our known expression, is V naught is equal to minus of R9 by R Thevenin multiplied by VTH. How much is R9? It is minus of R9 is actually 100. How much is R Thevenin? It is 500. How much is V Thevenin? It is minus 7.5. If you solve for this, this is actually 1.5 only. See now, you again got it as, sorry, this is 1.5 volt. So how did you get it as 1.5? So now instead of writing this minus 15 and then or discarding this, instead of doing all those things, of course this is certainly true that this is redundant. So you can retain this as minus 15, take it as 1k, take it as 100 ohm, write it as 1.5, or you consider this R8, find its VThevenin, find its RThevenin, and find out what is V0. You will get the same answer. You will get the same answer. So you have RThevenin, VThevenin coming here. Now let us do one more problem. So let us try to see. So in this particular case, this was becoming redundant. Let us see some cases where that resistor will not be redundant. Maybe in this case, you consider this case. This is now minus plus. If I take this as some 3 volt, and if you take this as, this is like, okay, let me take it as 5 volt, and then let me take this as, let me take it as 100 ohm, and this as some like, okay, 1k. So this is V0. Now can I treat this as redundant? Can I treat this as redundant? No, I cannot treat it as redundant. So let us see why I cannot treat it as redundant. So what is the voltage that you have here? The voltage that you have here is, so if I say this is V plus, what is V minus? V minus is actually 3 volt. What is V plus? V plus is actually how much? V plus is 5 into 100 divided by 1100. So how much is that? Is this actually 5000 divided by 1100? So can you see it is 4 point, sorry, so it's 500. Is it not 0.454 volt? So now the voltage V plus is 0.45, right? The V0 is actually how much? V0 is since V minus is greater than V plus, you will get V0 as minus V sat. So V0 is minus V sat. So perfect. Your V saturation is 15 volt. This will be minus 15 volt. This is the correct answer. This is the correct answer. Suppose if you take it as redundant, then it will be wrong. If you take it as redundant and if you say this is okay, you're going to get 5, then V0 will become, of course, you cannot neglect this. You cannot neglect this. Let me tell you why you cannot neglect. Okay, let us try to find out what is its Thevenin's equivalent. So what is its Thevenin's equivalent? If you see, look from here. So can I replace this entire circuit by something like this? Minus plus. This is now 3 volt. Can I now replace this by a V Thevenin and R Thevenin? This is V Thevenin. This is R Thevenin. What is V Thevenin? V Thevenin is 5 into 100 divided by 1100. So which is actually 0.454 volt. How much is R Thevenin? R Thevenin is actually 100 ohm in parallel with 1000 ohm. So which is I think 90, 100 inverse plus 1 exponential 3 inverse. Can you see it is 90.9 ohm? So this is 90.9 ohm. So how much is the voltage here? It is 3. How much is the voltage here? Because the current going here is 0. So entire voltage will reach there. It is 0.454 volt is V plus. How much is V minus? It is 3 volt. So naturally V0 is minus V sine. minus V second. So you have to consider this resistor. You have to consider this resistor. This is not redundant now. This is not redundant now. In the previous case, we consider it as redundant because the voltage here was same. Now, okay, forget about, don't take it as redundant at all. So you solve for this by using this technique. So by which technique? By finding R Thevenin, V Thevenin, you solve it so that you not have any ambiguity. So what did you do here? So I replaced this part of the circuit. So I replaced R7 R8 by something like this. So then you get it as, of course, if you're getting confused, okay, when to consider it as redundant, when to not to consider as redundant, replace this potential divider by its equivalent R Thevenin V Thevenin, then it will become very comfortable. It will be very comfortable. So this is your V Thevenin R Thevenin. Then there is no question of redundant anywhere. Redundant anywhere. So that will give you some confidence of analyzing the circuit. So you can see now, don't worry about whether it is redundant or not. So just find its equivalent Thevenin voltage Thevenin resistance, which is this here. So our V Thevenin is this is my R Thevenin. Then you replace this by a VThevenin circuit and a voltage source with VThevenin and a resistance associated with as R Thevenin, then you can easily solve the problem. You can easily solve the problem. I hope this will help you in analyzing the circuits. So whenever you're coming across some complicated circuits. Thank you.